In this video, we're going to take a look at derivatives of logarithmic functions. If you've watched the video on review of logarithms, then we're ready to get into some derivative calculations. The main formula that we need is the fact that the derivative with respect to x of log base b of x is equal to 1 over ln b times 1 over x. And this formula here just comes from the limit definition of the derivative. Now just a little caution here, some textbooks write this slightly differently. So we could also write derivative with respect to x of log base b of x is equal to log base b of e times 1 over x. So this is an alternative version of the formula. It still says exactly the same thing, but it's written a little bit differently. So let's think back to our change of base formula. So we talked about that in the video on review of logarithms. Remember that to calculate log to any base of any number, you take ln of your number and divide by ln of your base. And let's remember that ln of e is 1, because this is really just another way of saying log base e of e. So the exponent that we need to raise e to make e would be 1. And that tells us that this expression here is really just another way of writing 1 over ln b. So either formula is fine to use, but I think that the first one is a little bit easier, and that's the one that we'll focus on. So to get us started, let's try a few quick calculations. We're going to find f prime of x for a few different functions. So part A, our function looks like log base 2 of x. Well, our derivative, f prime of x, is going to look like 1 over ln of our base, so 1 over ln 2 times 1 over x. And we could write that a little bit more efficiently as 1 over x ln 2. So there's our answer there. For part B, let's say now our function is ln x. So it's important to remember here that ln is just another way of writing log base e. So we're really looking at log base e of x. And when we go to take our derivative, we're going to go 1 over ln of our base. So 1 over ln e times 1 over x. But again, remember that ln e is 1. So in fact, this coefficient here is just 1, and our answer is 1 over x. So this is one reason why the function ln x is particularly useful in calculus, because when we take its derivative, this coefficient here works out to 1. So in fact, it's our simplest logarithmic derivative. See, let's say our function is log base 2 of x cubed. And again, the problem here is to find f prime of x. Well, it might help here just to visualize this function that we've got log base 2, that's our outside function, applied to this inside function, x cubed. So when we take the derivative, we're going to be using the chain rule. Let's take the derivative of the outside function, the log base 2, and keep the inside function the same. So we would get 1 over ln of our base times 1 over our inside function, keeping that inside function the same, so that's why the x cubed is coming up in the denominator here. And then we need to multiply by the derivative of the inside function. So let's write a little reminder here in words of what we just did. We took the derivative of the outside function, and we kept the inside function the same. So that's why we've got an x cubed coming up in the denominator instead of an x, as in our simpler examples. Keeping the inside function the same here, we get an x cubed in the denominator, and then the rest of the chain rule says multiply by the derivative of the inside function. And this is the general pattern that we'll run into when we use the chain rule to differentiate logarithmic functions. Now, before we walk away from this, let's see if we can simplify our answer. So we've actually got 3x squared over x cubed ln 2. So yeah, we could do a little bit of simplification. Let's cancel a factor of x squared from the numerator and the denominator, and we'll have 3 over x ln 2. So there's a simplified answer there. For part D, let's say our function looks like ln of x to the 4th plus 1. And we're going to find f prime of x here. So again, we'll be using the chain rule because we've got an outside function here applied to an inside function that's more complicated than just a simple x. So we'll start with the derivative of the outside function and keep the inside function the same. Now remember that ln is really log base e. So our coefficient here is just going to look like 1 over ln of e, or if you want to say right away, that's 1, that's fine. So 1 over ln e times 1 over our inside function. That's the first part of our chain rule. And then we need to multiply by the derivative of the inside function. Okay, and now for our simplification. Remember ln of e, this is the exponent that e needs to be raised to make e. So that's definitely going to be 1. And what we've really got is 4x cubed over x to the 4th plus 1. And that's a nice simplified answer there. Let's say our function looks like ln cubed of x squared. And again, the problem is to find f prime of x. So just a little bit of notation here. What this really means is we've got the function ln of x squared, and the entire quantity is cubed. So it's similar to what we saw when we were looking at trig functions. If we saw something like sine cubed of x, that exponent that was sitting on our function really referred to one big exponent that was applied to the entire expression. So this is exactly the same thing as ln of x squared, all cubed. So definitely for the purpose of using the chain rule here, it will be useful to rewrite the function this way before jumping into our derivative. All right, so let's deal with the outside function, that's the cubed. We'll take the derivative of that, keeping the inside function the same. So 3 times ln of x squared all squared, and we'll need to multiply by the derivative of the inside function. And let's do that in our next step. Now, as we recopy this, we could start to simplify this first factor here. It's going to look like 3 times, well, let's write it 3 ln squared x squared. So we can put the 2 back on the ln function itself, and that means the same thing as having the ln x squared all squared. We're just now writing it in this shorthand here. But now what we really need to work on is finding the derivative of this function here, the ln of x squared. Well, according to the chain rule, it's going to be 1 over ln of e, and if you already remember that's 1, then we don't really need to write that down. So 1 times 1 over x squared, that's the first part of our chain rule, and then we need to multiply by the derivative of the inside function, so times 2x. So we've really used the chain rule twice here. We used it in the first step to deal with the cubed, and we've now used it again in taking the derivative of the ln of x squared. Now at this point, we just need to simplify our answer a little bit. So as we pointed out a little bit earlier, ln of e was 1. So that simplifies this coefficient here. If we start to clean this up a little bit, we've got 3 times ln squared of x squared. We've also got a factor of 2x in the numerator and an x squared in the denominator. So we can cancel a factor of x from the numerator and the denominator, and we can also combine the 3 and the 2 in the numerator. So let's make it 6 times ln squared of x squared over x. Or alternatively, you could write this 6 times ln of x squared all squared over x. So the two expressions mean exactly the same thing. Okay, for our last example, let's find f prime of 4 when f of x looks like ln of x plus 1 over x minus 1. Now, in this type of problem, it really pays to simplify f of x before taking our derivative. So let's think back to our log rules. If you don't remember the rules for simplifying logarithms, you can take a look at our review of logarithms video. But remember that whenever we have ln of a quotient, so ln of a over b, you can rewrite this as ln of your numerator minus ln of your denominator. Now, let's compare these two functions for a minute. If we were to take the derivative of the function as it was originally written, we'll have to do a chain rule. And not only that, but when we're calculating the derivative of the inside function, there will be a quotient rule involved. So that's not going to be so fun. You will be able to solve the problem that way, but it will just be a little bit longer. However, since we've now simplified our function, yes, we will have to use a chain rule for each of these terms here, but it will now be much simpler. So let's find f prime of x. We've got a ln function here, so that's log base e. Our derivative is going to look like 1 over ln e, which is just 1, times 1 over our inside function, times the derivative of our inside function. So this was really a chain rule here. And then we're going to subtract off 1 over ln of our base, so 1 over ln e, times 1 over our inside function, times the derivative of our inside function. So again, another chain rule here. Derivative, we got the derivative of the outside function, keeping the inside function the same, times the derivative of the inside function. So I'm just going to write chain rule under both of those expressions. Okay, and then we can simplify a little bit. Remember that ln of e is just 1. So we're really looking at 1 over x plus 1 minus 1 over x minus 1. Now I wouldn't do too much more simplifying than that because we are going to plug in a value here. Remember the question was asking for f prime of 4. So f prime of 4 is going to be 1 over 5 minus 1 over 3. Okay, and let's just multiply the first term there by 3 over 3. So we got 3 over 15 minus, and if we take our second term here, let's multiply it by 5 over 5. We've got minus 5 over 15, so that gives us -2/15 as our final answer.